Greedy algorithm. In the greedy algorithm training program, we will introduce the following in order: optimization problem, concept of the greedy algorithm, computation process of the greedy algorithm, and application of the greedy algorithm. First, you need to understand the meaning of the optimization problem. The optimization problem can be defined as follows. A given problem may have a number of solutions, and you hope to find out an answer that contains the best value, such as maximum value or minimum value, and this answer is called the optimal solution. Interestingly, there may be more than one optimal solution. Many algorithms can be applied to solve the optimization problem. Among them, the greedy algorithm is the method that can be used to find out the optimal solution in the most intuitive way. Before we get into the greedy algorithm, let us think about what will be the best timing for applying the optimization problem. During our daily work, you may apply the optimization problem in our work in order to calculate the method that can accomplish the most tasks within the shortest period of time, or visit the most places with the least time when planning a trip, or exchange the least coins when refunding changes. In fact, these things that we have frequently encountered during our daily life are optimization problems. After knowing about the optimization problem, let us start our topic to find out what the concept of the greedy algorithm is. The greedy algorithm is a process that can be applied to segment the problem into several subproblems. In each subproblem, the seemingly best option determined at that time is applied. Through the repeated selections of individual optimal solutions, they are finally consolidated into the global optimal solution. Each individual option is determined according to specific criteria and will be irrelevant to any decision being made. Before and after the determination process, the greedy algorithm is suitable for the optimization problem. Although the greedy code may be difficult to find, it would be very convenient and efficient for use once it is unveiled. How to realize the greedy algorithm? The computation process of the greedy algorithm comprises the following 3 steps, and they are greedy code, feasibility check, and solution check. When solving a problem, you need to repeat the previously mentioned 3 steps until an answer is concluded. As a first step, you need to create the greedy code. The greedy code is also called the selection procedure. It means you need to create a code that can be used to select individual optimal solution to select the next item to add into the solution set. Next step is the feasibility check. It is a process executed to check if the solution set complies with the requirements established for the subject after new items are added. The final step is the solution check. In this step, the newly created solution set will be checked to see if it is the final solution for this problem. In the following examples, we will show you that the feasibility check and the solution check steps can be ignored for the subject that can be solved through the greedy algorithm process. It will present the primary greedy code only. Let us show you a practical example. Application of greedy algorithm, refunding changes 1. Here are the paper bills and the coins representing a face value of $1,000, $500, $100, $50, $10, $5, and $1 respectively. Please design a program that can be applied to input in dollar value so that the program will present the least number of face value portfolio. Input instructions. Input several lines at a time, with each line containing 1 digit to represent the money to be refunded. For example, if the input examples are 28 and 1541, then they refer to $28 and $1,541 respectively. Output instructions. Each line will output the least paper bill and coin portfolio. Sequentially, they represent the quantity of paper bills and coins in the face value of $1,000, $500, $100, $50, $10, $5, and $1 respectively. They are separated by an empty space with each other. Therefore, the least paper bill and coin portfolio corresponding to $28 will be 2 10s, 1 5, and 3 1s. As for $1,541, it will comprise 1 1,000, 1 500, 0 100s and 50s, 4 10s, and then 1 $1, but there aren't any $5. I believe you are already familiar with the action of refunding the small change. If so, how can $28 be created through the paper bill and coin portfolio? First, $28 can be exchanged into 2 tens with $8 remaining. Next, $8 can be exchanged into 1 5 with $3 remaining. Finally, $3 can be exchanged into 3 ones. As such, we have 2 tens, 1 5, and 3 ones. As a matter of fact, the greedy code exists in the small change refunding process. We know that during the small change refunding process, we used to ask for the paper bills or the coins bearing larger face value, and then the smaller face value after that. Here, this kind of larger face value first and then smaller face value rule is called the greedy code. After finding out the greedy code, to accomplish the task, we may separate the entire process into the following 3 steps. Step 1. When processing the highest face value, calculate the number of paper bills or the small change that can be exchanged with the current amount. It is the quotient acquired by dividing the amount with the face value. Step 2. Calculate the amount currently remained. It will be the remainder acquired by dividing the original amount with the face value. Step 3. When processing the second highest face value, repeat Step 1 and Step 2 until all face values are calculated in the order from large to small. Let's take a look at the reference program code. Because we have 7 different types of face values, they should be initialized into an array represented by the value of 7. Arrange the face values in the order from large to small. Next, add variable n to represent the amount of money. Finally, access the for loop of the main body of the algorithm. In this case, the for loop will execute the following tasks. Acquire the quotient by dividing $in with VI for all face values sequentially. It represents the quantity of paper bills or small change that can be refunded for the respective face value. The if-else condition judgment is used to output the value of the quantity that can be refunded for the respective face value. Separate them with an empty space in between. Now you can get a program that can help you convert to the least coins or paper bills. Application of greedy algorithm, relaxed supermarket clerk. Remember this kind of experience? When you are buying a $10 object, you pay one $100 bill, and the clerk refunds you with 9 tens, and some would even refund you with 5 tens, 6 fives, and 10 ones, and so on. To avoid this kind of situation, a supermarket has prepared sufficient quantity of small change in each of its stores and asks its clerks that the quantity of small change refunded to the customer must be kept at a minimum level. It is known that the currency used in this country comprises the following 9 kinds of paper bills, and they are $1, $5, $10, $50, $100, $500, $1,000, $5,000, and $10,000. Can you help this clerk solve this problem? Input instructions. First, input a positive integer n. N is greater than or equal to 1 and less than or equal to 10 to the 5th power. It represents the money that should be changed. Output instructions. Please output the least quantity of small change when changing $in to the customer. In the input and output examples, 17 represents the $17 in change that the clerk should give back to the customer, and the $17 can be comprised of 4 coins. In addition, 99 means $99 that should be refunded by the clerk, and 10 coins can be put together to become $99. In refunding small change 1 subject, there are the paper bills and the coins representing the face value of $1,000, $500, $100, $50, $10, $5, and $1 respectively. By adding one more face value of $18, will the greedy code still be applicable? Let's assume that $28 is the amount that should be refunded, and that this $28 can be exchanged into one $18 and one $10. You can still acquire the optimal solution through the greedy algorithm. If the amount to be refunded is $25 and the refunding process begins from the largest face value through the greedy algorithm, then it can be exchanged into one $18, one $5, and two $1, with a total of 4 coins. However, is this result the optimal solution? We can also change $25 into 2 10s and 1 5. Since only 3 coins are required, it is the optimal solution that we want. With the additional $18 face value, the original greedy code will no longer be applicable. Application of greedy algorithm, working schedule. It is assumed that n number of jobs will be assigned to one of the machines, and each job is provided with a selected starting and ending time. Each job should be executed one at a time. The job must be completed once launched and cannot be switched to another job. Let's assume that this machine is designed with an extremely quick job switching time that can be ignored. How many jobs can be completed by this machine at most? Input instructions. First, input n to represent the number of works that should be executed. The n should be smaller than 150. Next, input n lines of numbers, where each line requires 2 integers that we will represent using s and e. S means the work starting time, and E means the work ending time, and S must always be smaller than E. Output instructions. Output a digit to represent the maximum number of jobs that can be completed when the machine stops running. Let us look at the input example. In the input example, the first integer, 6, means that there is a total of 6 different types of jobs. Therefore, 6 lines of digits should be entered below to represent the starting time and the ending time for these 6 types of jobs. 1 and 11 mean that the starting time of this job is 1 and the ending time is 11. 6 and 9 mean that the starting time for this job is 6 and the ending time is 9, and so on. On this basis, this input example can be drafted into the job schedule to the right. Now, let's figure out the maximum number of the previously mentioned 6 types of jobs that can be completed simultaneously. If job 1 is done, it seems that the machine will be able to complete 1 job only. If job 3 is done, then the machine can only execute another job 2 or job 4, so there will be 2 jobs. If job 6 is done, then the machine can also complete job 4 and job 5. This seems to be our answer. Therefore, 3 is the result in the output example, and it means the machine will complete 3 jobs at most, and they are job 6, job 5, and job 4. Next, let's see how to find the answer. First, we must create the greedy code. In this application, our greedy code must select the earliest ending time with no overlapping executed jobs. During the first round of selection, select job 6, showing the earliest ending time. Next, select job 2, job 4, and job 5 that did not overlap with job 6. Then select job 5, showing the earliest ending time among job 2, job 4, and job 5. Finally, select job 4. The result is that a total of 3 jobs can be completed. Let us separate this process into the following 3 steps. Step 1. Sort all jobs according to the order of their ending times, and then select the first job. First, sort the n number of jobs according to the order of their ending times, and select the job that has been completed the earliest. Then add 1 for the number of jobs that can be executed. Here, the one completed first is job 6, and the current number of job is indicated as 1. Step 2. Let's select the starting time of the remaining jobs equivalent to or later than the ending time of the work currently being executed. We can see that job 3 overlaps with job 6, so job 3 will be abandoned. Since it does not overlap with the starting time of job 5, it can be added for execution, and then the number of the job will be increased to 2. Step 3. Repeat step 2 until all jobs are duly inspected and you get the maximum number of jobs that can be executed. Next is job 2, overlapped, abandoned. As for job 4, it can be added because the starting time has not overlapped with the ending time of job 5, and the resulting job quantity is indicated as 3. The last job 1 cannot be added because it is overlapped. Now you have completed the inspection of all jobs. Now let us look at the reference program code. First, create a structure named job. This structure comprises 2 types of integer variables, and they are s and e, representing the starting time and the ending time of this job. After creating the structure, start the initialization of the desired array that contains a job type named JB with a size of 101. Next is the CMP function. This function will be implemented in the sort function later for sorting all jobs in the order of small to large according to their ending times, After that, save the number of jobs in variable N. Save the starting and ending time of the job being logged by the user in the JB array. Sort all jobs in the order from small to large according to their ending times. Initialize the variable named ANS to calculate the number of jobs that can be executed. In this for loop, initialize the variable named now2 minus 1, and this variable represents the current time. Because the job has not been started yet, so it is coded as -1. Next, compare the starting time of each job to see if it is greater than or equal to the now variable. If yes, it means that this job is ready for execution. Add 1 to the variable ANS and set the now variable value as the ending time of the next job. Now you have completed the setting procedure. Application of greedy algorithm. Who finishes the supper first? Let's assume that N persons are having supper in a restaurant, and the cooking time of the chef for each course is different. The time required for each person to finish their supper is different too, and the course can only be cooked one at a time in the restaurant. How should the chef arrange the cooking sequence so that all customers can finish their suppers and leave the restaurant as soon as possible? Input instructions. Input several entries of test data. The first line is indicated as an integer N, representing N persons are enjoying their meals. If N equals 0, it represents the test data is ended. Next, input N lines with each line containing 2 integers, and they are C and E, representing the course preparation time and the dining time of each customer. N less than or equal to 10 to the power of 5. C is greater than or equal to 1, and E is smaller than or equal to 10 to the power of 5. Output instructions. Output 1 line for each test data entry, representing the leaving time of the last customer, when the chef is preparing the food under the optimal cooking scenario. Let us look at the input example and the output example. In the input example, the first integer, 2, represents that there are 2 customers. In the meantime, 11 and 8 mean 11 units of cuisine preparation time required for the first customer, and 8 units of dining time respectively. Next, 7 and 10 mean that 7 units of time will be required in preparing the cuisine for the second customer, and he will be able to finish the meal in 10 units of time. As for 26 in the output example, it means the total duration of 26 units of time, starting from the chef preparing the cuisine for the first customer to the time when the last customer leaves the restaurant. Next, you may keep inputting. Here, 3 means 3 customers, and then 11, 22, and 33 represent the cuisine preparation time and the dining time of these 3 customers. The output result is 7. Finally, input 0 to complete the entire program. Here, the applicable greedy code is defined as below. Prepare the cuisine for the customer requiring longer dining time first. Taking the customer being input for the first group of example, for instance, it contains the preparation time and dining time required for customer A and customer B. According to the greedy code, customer B requires longer dining time, which allows the chef to prepare the cuisine for customer B first. Let us visualize the entire process. First, prepare the course for customer B, and customer B can start eating after it is prepared. Then proceed with the cuisine for customer A. In this way, the time when the last customer leaves the restaurant will be defined as 7 plus 11 plus 8 equals 26. After perceiving the entire logic concept, you may start turning the subject into program code. Greedy algorithm. Application of greedy algorithm. Backpack problem. Let's assume that we have n pieces of objects in one backpack, and that the load capacity of the backpack, as well as the value and weight of each object, are already known. You may separate the objects and then put some of them into the backpack. Now, calculate the maximum value of all objects that can be loaded into the backpack within the load capacity of the backpack. Input instructions. Input n digit per time, where n means the quantity of the object and should be less than 100. After that, input n lines with each line containing 2 integers, w and v, for which w means the weight of the object and v means the value of the object. Finally, input integer k to represent the load capacity of the backpack. Output instructions. Output a value, rounded off to the second decimal place, to represent the maximum value of all objects that have been loaded into the backpack when calculated within the load capacity of the backpack. Input example and output example. In the input example, the first integer, 3, refers to the quantity of the objects. For the convenience of explanation, we'll call them Object A, Object B, and Object C. As a next step, input the weight and the value of Object A, Object B, and Object C respectively. The weight and the value of Object A are expressed as 6 and 12 respectively. The weight and value of Object B are expressed as 4 and 4 respectively. The weight and the value of Object C are expressed as 7 and 21 respectively. The last digit of 15 represents the load capacity of the backpack, meaning the maximum total weight that can be loaded is 15. In the output example, the digit of 35 represents the maximum value of all objects that have been loaded into the backpack. To solve the aforesaid application with greedy algorithm, you need to create the greedy code as below. First, calculate the unit weight value of all objects. Sort all objects in order from large to small based on their unit weight values. Select the object with the largest unit weight value and then start the loading process. Simply put, load the most cost-effective object first. In the input example, the backpack load is 15. First, calculate the unit weight value of each object, and then sort them in the order from large to small. Next, let us load the objects into the backpack. Select Object C with the largest unit weight value, and then put it into the backpack first. Since the load capacity of the backpack is greater than the weight of Object C, all of them can be loaded into the backpack. The remaining load capacity of backpack is calculated as 15 minus 7 equals 8, and its value is 0 plus 21 equals 21. Because the backpack is not fully loaded yet, select Object A, showing the second largest unit weight value, and then load it into the backpack. Since the remaining load capacity of the backpack is still greater than Object A, all of them can also be loaded into the backpack. The remaining weight of the backpack is calculated as 8 minus 6 equals 2, and its value is 21 plus 12 equals 33. Because the backpack is not fully loaded yet, let's continue to load Object B, showing the third largest unit weight value. However, only 2 units can be loaded because it is impossible to put all of Object B into the backpack. Finally, the remaining load capacity of the backpack is calculated as 2 minus 2 equals 0. Therefore, its total value will be 33 plus 2 equals 35. After understanding the breakdown steps, we can divide the problem-solving process into the following 3 steps. Step 1. Select the object showing the maximum unit weight value and then put it into the backpack. Step 2. Repeatedly select the object showing the maximum value from the remaining objects until the backpack is fully filled without any additional space, or all objects are loaded into the backpack. Step 3. Separate the objects that cannot be loaded and then stuff them until it reaches the max weight limit of the backpack. After that, you may acquire the maximum value for the bearing capacity. Let us look at the reference program code. First, create a structure named OBJ. This structure comprises 3 types of integer variables, and they are W, V, and VW, in which W represents the weight of the object, V means the value, and VW refers to the unit weight value. After creating the structure, start the initialization of the desired array. That contains an OBJ being coded with OB, as the pattern name and configured as 101 in size. Next is the CMP function. This function will be implemented in the sort function later to sort different objects in the order from large to small according to their unit weight values. After that, save the number of the objects in variable n. Input the weight and the value of each individual object. Sort all objects in the order from large to small according to their unit weight values. Save the load capacity of the backpack in variable k. Initialize the variable named total v to save the values of the objects in the backpack. In this for loop, you may check if the weight of the object is smaller than or equal to the remaining load capacity of the backpack. If it meets the required condition, load the object into the backpack and then deduct the weight of the object from the load capacity of the backpack. If it fails to meet the required condition, select the maximum objects that can be loaded into the backpack. Finally, output the total value of the load in the backpack, round off to the second decimal place. Application of the problem not suitable for greedy algorithm. 0-1 backpack problem. Let's assume that we have n objects and one backpack, that the load capacity of the backpack as well as the value and the weight of each object are already known, and that you can only select or not select the desired object instead of putting some of them into the backpack. Next, acquire the maximum value of all objects that have been loaded into the backpack when calculated within the load capacity of the backpack. What will happen if we continue using the greedy algorithm? Same as above, let's assume that the weight acceptable by the backpack is 15. There will be the following three objects that can be selected. Object A with weight and value 6 and 12, Object B with weight and value 8 and 14, as well as Object C with weight and value 7 and 21 respectively. Based on the greedy code being created in the previous example, select Object C showing the maximum unit weight value and then put it into the backpack first. Because the load capacity of the backpack is larger than the weight of Object C, all of them can be loaded into the backpack. Now, the remaining load capacity of the backpack is calculated as 15 minus 7 equals 8. Therefore, its value will be 0 plus 21 equals 21. Next, select Object A showing the second largest unit weight value. Because the load capacity of the backpack is still higher than Object A, all of them can be loaded into the backpack. At this time, the remaining weight of the backpack is calculated as 8 minus 6 equals 2. Therefore, its value will be 21 plus 12 equals 33. Is this option the optimal solution? Let us take a look at the other options. Same as above, let's assume that the weight acceptable by the backpack is 15. Similarly, select Object C showing the maximum unit weight value. Because the load capacity of the backpack is larger than the weight of Object C, all of them can be loaded into the backpack. At this time, the remaining load capacity of the backpack is indicated as 15 minus 7 equals 8, so its value will be 0 plus 21 equals 21. Next, select Object B that can just fill up the backpack and then put it into the backpack instead of selecting Object A showing the second largest unit weight value. Because the load capacity of the backpack is equal to the weight of Object B, all of them can be loaded into the backpack. Now, the remaining load capacity of the backpack is calculated as 8 minus 8 equals 0. Therefore, its value will be 21 plus 14 equals 35. Compared to the value of 33 acquired from greedy algorithm, more values can be acquired from this option. Therefore, it will be regarded as the optimal solution to the current subject. Not all problems can be solved with a greedy algorithm. Application of greedy algorithm. Strengthen the immunity by eating fruits. To fight against the COVID-19 pandemic, the entire world is under alert status. In addition to washing hands, wearing face masks, and disinfecting the environment frequently, it is also crucial in strengthening personal immunity, especially vitamin C. In this case, vitamin C can be ingested through vegetables and fruits. Under the preconditions of not spending $M on buying fruit each day, you need to know which kind of fruits to purchase in order to obtain the maximum content of vitamin C. Let's assume that fruit can be sliced into gram unit easier for making the purchase, and that the amount of each kind of fruit ingested should not be more than 100 grams. Input instructions. Input N digit each time. Here, N means the number of fruit types, and this N should be less than 100. After that, N lines will be indicated with each line containing 2 integers, representing the amount of vitamin C contained in 100 grams of fruit, and the price for each 100 grams of fruit. Finally, input an integer M to represent the daily maximum limit to spend on fruits. Output instructions. Output a value, rounded off to the second decimal place, and it represents the maximum vitamin C content that can be ingested within the daily fruit expense limit. Input example and output example. In the input example, the first integer 6 means that there will be 6 kinds of fruits. Next, the 2 digits of each line represent vitamin C content per unit and price per unit. In the final line, digit 30 represents the budget spent on buying the fruit. In the output example, the digit 497 means that you can purchase the fruit containing 497 milligrams of vitamin C by spending $30. When solving the aforesaid application through the greedy algorithm, you need to create the greedy code as shown below. Sort the vitamin C content for all kinds of fruits in the order from high to low according to the unit price. Then, purchase the fruit showing the highest unit content of vitamin C first. Next, let us break down the entire procedure in order. The expense spent on buying the fruit is set at $30. Now, let us find out 6 kinds of fruits and include them in the example subject, and they are guava, pineapple, citrus orange, kiwi, lemon, and strawberry. Next, calculate the vitamin C content per the unit price of all fruits, and then sort the vitamin C content according to the unit price. After that, purchase the fruit that contains the highest vitamin C content per the unit price, for example, guava. Now the expense is indicated as 30 minus 8 equals 22, and the total vitamin C content will become 0 plus 245 equals 245. Next, purchase the fruit that contains the second highest vitamin C content per the unit price, for example, pineapple. Now the expense is calculated as 22 minus 4 equals 18, and then the total vitamin C content will become 245 plus 80 equals 325. Then the citrus orange that contains the third highest vitamin C content. Now the expense is calculated as 18 minus 5 equals 13, and then the total vitamin C content will become 325 plus 58 equals 383. And next, the kiwi fruit. Now the expense is calculated as 13 minus 10 equals 3, and then the total vitamin C content will become 383 plus 90 equals 473. Finally, we buy lemons that contain the 5th highest vitamin C content per the unit price. Because the remaining money is not enough for buying an entire lemon, so we only buy 3/7 of a lemon. Until now, the expense is calculated as 3 minus 3 equals 0, and then the total vitamin C content will become 497. Next, you can actually practice the program code. Let us look at the small change refunding subject in the greedy algorithm. Here are the paper bills and the coins representing the face value of 1,000, 500, 150, 10, 5, and $1 respectively. Please design a program that can be applied to input in dollar value so that the program will calculate the least number of face value portfolio. Next, let us look at the input and output instructions. Input instructions. Input several lines each time, with each line containing a digit to represent the refunded money. Output instructions. Each line will output least quantity of paper bills and coins combined by 1,000, 500, 100, 50, 10, 5, and $1 paper bills and coins, separated by an empty space in between. What is the meaning of input and output here? Let us take a look at the format of the example provided below. First, let us input the amount of $28, and it means that the money to be refunded is $28. The output will output the number of 1,000, 500, 100, 50, 10, 5, and $1 required. The foremost quantity is $1,000, followed by that of $500, and that of $100, and then 50, 10, 5, and $1. Take $28, for instance. Because the user does not require $1,000, $500, $100, and $50, so the top 4 paper bills will be shown as 0. And the exchange for $28 will start from $10. We'll start by exchanging 2 10s, and then $8 will remain from the $28. As for $8, we can change it with one $5 bill, and then $3 will remain. Now, there will be 3 1s left. These are the quantities that we want to output. Similarly, what will the quantities be for 1,541? In the case of 1,541, we will need one 1,000 and one 500, and then $41 will remain. So $100 and $50 paper bills will not be required. Likewise, $41 can be refunded into 4 tens, and then $1 will remain, and you may input $1 directly. Again, $5 coins will not be required. These are the input and output that we want. Then, how should we write this program code? First, let us create the required architecture. For example, include IOStream. It is the architecture required for executing C in, C out. Next, create using namespace stand. And then create the required primary program code field. Do not forget to execute the return 0 step. Here, we see the following face values, and they are 1,000, 500, 100, 50, 10, 5, and 1. Therefore, you need to save the aforesaid face values so that the PC will know about the total quantity of the money that should be exchanged. Now, let us create an array named VI, and it will be used to save the paper bills shown in the previously mentioned face value. Save these paper bills in the following sequence: $1,000, $500, $100, $50, $10, $5, and then $1. Next, you will need to input a digit to represent the quantity of paper bills that will be refunded, and they will be executed in multi-line input and output pattern. Here you need to create a variable n so that you may execute the input process more easily. In the while cn field, execute the cn step to input n repeatedly. When inputting the amount each time, you need to check if it will be available for refunding $1,000. If negative, search the rest of other amounts to see if they will be available for refunding $500. Regardless of whether it can or not, you will need to check the rest of 100, 50, 10, 5, and 1. One by one, after completing the aforesaid step, you need to check each of them, and then you will know the quantity that will be required for each individual face value. Therefore, you need to check the status of these 7 face values repeatedly. For this purpose, you need to execute this process through for loop. Because there's for I equals 0 in the for loop, it means that a maximum of 7 I++ will be required. In the for loop, the task that you must execute is to output the status of each individual face value. Therefore, it can be processed like the following. When receiving the money, check the first item, VI, and it should be the $1,000 status. Check what its quantity will be when acquiring the quotient by dividing VI with n. If it is 1,541, then the quotient will become 1 when dividing it with 1,000. It means that you need one 1,000 paper bill. If it is 28, then the quotient will become 0. When dividing it with 1,000, it means that you don't need that $1,000. Because an empty space will be required here, let us also try to output the empty space when outputting the figure value. After outputting the empty space, if we divide 1,541 by 1,000, then n value that remains must be 541. It means that we need to process this n. In this case, n will be the remainder after dividing n with VI. Like the aforesaid 1,541. The figure 541 will remain after dividing it by 1,000. In this case, it is the remaining amount. When acquiring the remainder by dividing 541 by 500, the figure 41 will be left. When acquiring the remainder by dividing 41 by 100, the figure 41 will be left. When acquiring the remainder by dividing 41 by 50, the figure 41 will be left as well. Whether paying this paper bill or not, you will obtain the status that should be represented for N, and it is exactly what we want. After finishing this line, we may change to next line according to output process. Next, let's see what the result will become. First, let us input 28 and see what will happen. You can see there 0, $1,000, 0, $500, 0, $100, and 0, $50. There are 2 10s, 1 $5, and 1 $3, and they are consistent with our data. What about 1541? It looks like that is consistent with the test data that we obtained a minute ago. There is 1 $1,000, 1 $500, and 4 10s, but there isn't any 100 or 50. There isn't any $5, but there is one $1. So let us submit this amount. What is this? How come they're all wrong after submission? It looks similar to our data, but why are they all incorrect? Let us run the entire process again to see what happened. 41 is shown, and 1541 is also shown. It seems they are correct. Let's take a look here. Do you see that? An empty space exists at the rearmost end of 1. Here it is. Do you see it? Same for this line. There's an empty space at the rearmost end, but there isn't any empty space in the test data because it is said to separate them with an empty space in between during the output process. Therefore, there should not be an empty space at the rearmost end. Then how should it be modified? The part that should be modified is the output part. During the outputting process, there should not be an empty space after every digit. So make sure that there is no empty space at the rearmost end. Therefore, there are 2 aspects that we need to consider. First, do not output the empty space for the last one. If you are not sure about the last quantity at this time, it would be slightly complicated. Normally, you need to deal with the first one beforehand because you are sure what the first one will be. The first one is at I, and it will become the first one when being set at 0. At this time, the first step is allowing it to output the digit instead of empty space or other kinds of unwanted items. If it is not the first one, let it output the empty space. Here, special attention will be required. You need to shift the empty space to the front for outputting. Because we do not output the empty space for the first one, so it will output 0 only. Next, each digit should be followed with an empty space and a digit. So an empty space should be placed first and then followed with a digit, and this is a correct output method. Let us run it again. Same as the above, let us input 28 and then check the rearmost end. Do you see that there are no empty spaces following the digit 3 now? Again, for 1541, we can see that there isn't any empty space following the digit 1. And this is the result that we want. Let us submit it again. Correct. All of our test data has passed the inspection. That's how it is for this subject. Please practice if you haven't keyed in the program code yet. Now let us look at how the greedy algorithm is operated. Relaxed supermarket clerk. First, let us take a look at the test subject. Do you have any experience like this? You buy something that's $10 and you pay a $100 bill. But the clerk refunds you with 9 10s, or even 5 10s, 6 5s, and 10 1s. Isn't that annoying? To avoid this kind of situation, a supermarket has prepared sufficient quantity of small change in each of its stores and asks its clerks that the quantity of small change refunded to the customer must be kept at the minimum level. It is known that the currency used in this country comprises the following 9 kinds of values. They are 1, 5, 10, 50, 100, 500, 1,000, 5,000, and 10,000. Can you help the clerk solve this problem? Let us take a look at the input and output instructions. Input instructions. Input a positive integer n, with n ranging from 1 to 10 to the power of 6. It represents the amount that should be refunded. Output instructions. First, output the least quantity of small change when refunding in dollar to the customer. Then, how should this section of program code be written? First off, let's create the C++ format. In order to include the elements that should be included, like the required IO stream, and then using namespace stand. Next, create the required primary program code field. Do not forget to execute the return 0 step. After creating the main architecture, let's think about where to start the program code. First, let us review the following phrase. This country uses the following 9 types of currencies: 1, 5, 10, 50, 100, 500, 1,000, 5,000, and 10,000. Now, let us create an array to save the following 9 types of currencies. And they are 1, 5, 10, 50, 100, 500, 1,000, 5,000, and 10,000. However, we need to refund small change this time, and we usually begin with the currency bearing the highest face value. For example, if I need to give the customer $130 in change, I will start with the highest currency of $100. When executing the refunding in the order from small to large, it would be more complicated when writing the program. In other words, you may sort the array in the order from large to small. Start with $10,000 bills first, followed by 5,000, and then 1,000, 500, 100, 50, 10, 5, and finally $1. By creating this kind of array, it will be more convenient when running the program later on. Therefore, you may delete the above. What should we do next? Now, let us look at the input part. You need to input a positive integer n representing the amount that should be refunded. For this purpose, let us create an integer n. Input this integer n with while cn. The least quantity of bills when outputting in dollar for refunding to the customer. In this case, it is only required to know about how many coins should be refunded. At this time, you need to select a sum to carry out the statistical calculation to see how many coins should be refunded to the customer. Then, let us look at all of the coins. Based on the for loop, you need to check the money ranging from $10,000 bills to $1 coins. If $10,000 should be refunded, then our sum will be increased. If $5,000 should be refunded, then the sum will be increased accordingly. If $1,000 should be refunded, then the sum will be increased as well. But how will it be increased? Remember the method mentioned above? By dividing n with vi, you may acquire the quotient resulting from dividing n with vi. Let's assume that n is 130. Then the quotient will become 0 when divided by 10,000. So, it doesn't matter even though the sum remains unchanged. The quotient for 5,000, 1,000, and 500 will also be 0, and that doesn't matter either. When dividing 130 by 100, the quotient will become 1, and it means that $100 will be refunded, and then your sum will increase accordingly. What will happen after the refunding? Certainly your n will change, and n will become n percentage vi after that. Let us take a further look. The remainder will still be 130 when using 130 versus 10,000 in the calculation. The remainder will still be 130 when using 130 versus 5,000, 1,000, and 500 in the calculation. However, the remainder will become 30 when using 130 versus 100 in the calculation. By refunding one $100 bill, the number of the remaining small change is 30. This is our method. After solving the problem, you will be allowed to output the resulting sum. Let us look at the execution result. What is this? I see a problem there. I just mistyped a letter, and it should be V. Now, let us run the program again. If you input 17, it will show 4. That should be refunded. Now, you can check if such result is a correct one. If inputting 17, it will become one $10, one $5, and two $1, and so the answer 4 is correct. Let us check the second test data. It is using 99. Let us input it and see. The result of 99 is 10. You can also check if it is correct. Have you finished checking? It's all right. Let's take a look together. If it is 99, then 100 will not do. Therefore, it should be 150. After refunding 50, the remainder will be 49, and so it will be 4 tens, and then $9 will be left, and it comprises one $5 and 4 ones. The result will become 150, 4 tens, 1 5, and 4 ones, which will make a total of 10 coins. Is that clear enough to you? If yes, let us submit this subject to see whether or not it will be accepted. Wow, great! All of our test data have passed. This is how the program is written for relaxed supermarket clerk. Now, let us check the working schedule in greedy algorithm. Let's assume that n number of jobs will be performed by a machine, and each job has fixed starting times and ending times. The machine is allowed to execute the job one at a time. Once a job has started, the machine must complete the job and cannot switch to another job. Let's assume that the job switching time is very quick and it can be ignored. How many jobs can be completed by this machine at most? Let us look at the input and output instructions. First, a digit n will be input, representing the number of jobs to be executed. The setting for n must be less than 150. Next, input n lines of digits with each line containing 2 integers, and they are S and E. S means the job starting time, and E refers to the job ending time. However, S is always smaller than E. Output instructions output a digit to represent the maximum number of jobs that can be completed when time is up. Then, let us look at the input and output in the example. To begin with, input 6, meaning that 6 jobs will be input later on. Among these 6 jobs, each line will contain 2 digits. The first digit represents the job starting time, and the second one represents the job ending time. So here we have 6 jobs, and they are 1, 11, 6, 9, 2, 6, 8, 10, 4, 8, and 1, 4, respectively. The output result is the maximum number of jobs that can be completed among the aforesaid 6 jobs. Next, we will use the greedy algorithm strategy, and the job that will finish first will be selected first. Next, we will select the job that is neither repeated nor overlapped, and that can be finished first. It means that among these 6 jobs, we will select 1-4 job that can be finished first. The next job will be finished is 2-6. But 2-6 overlaps with 1-4, and we do not want to select it. Instead, the 4-8 job will be selected. Because the work shifting can be ignored, so you may select 4-8 after finishing 1-4 job. The next job that can be finished is 6-9. Because it is a repeated job, so it cannot be selected. Then the job that we should select will be 8-10. Finally, the 1-11 job is also repeated and it cannot be selected. We have selected a total of 3 jobs, and they are 1-4, 4-8, and 8-10. Have you ever wondered why we select the jobs that end the soonest first? When they're classified by time, we may have the following 3 options. Select the job that starts first, select the job that finishes first, or the one that requires the shortest time. Selecting the job that starts first is obviously a mistake. In the selected 1-11, 1 is the job that starts first. Because in 1-11, all jobs are repeated, and it is obviously a wrong selection. Maybe selecting the job that requires the shortest time feels right to you. I'm sure everybody has wondered about this before, but let me give you an example. As far as these jobs are concerned, the shortest one will be 4-6 job. If we select 4-6 job first, then it has overlapped with 1-5 and 5-10, and they are out of the selection list, so there will be only 1 job left for selection. However, we may analyze this matter by first finishing approach. As 1-5 is the job that's finished first, we select 1-5. Because 4-6 has been overlapped, it will be ignored. Because the next 5-10 job has been finished first, so we select 5-10. This way, 2 jobs are selected. So our strategy will be the selection of the job that can be finished first. Then, how should we write the program code? First, let us create the format required for C++. Include IOStream using namespace stand. Same as above, create a primary program code field. Do not forget to execute the return 0 step. Next, what should be written? To begin with, you need to input a digit in, and then the PC will input in lots of jobs. For each individual job, you need to input 2 integers, and they will be S and E respectively. For the convenience of distinguishing S and E, they will be the elements covered in the same group. We can use certain structure to create another structure in order to bind our S and E. This way, they will not be separated due to careless operation. After creating the desired structure, you need to load S and E into the structure. This way, you can be sure that they will be tied together. Next, you need to initialize an array and a structural array. Because n is always smaller than 150, we need to set a maximum total of 150. When creating the structure, it should be followed with a semicolon. Next, you need to input n. Therefore, you will create a variable n to run the cn. After inputting in, it is required to input in job entries. In this case, you will use a for loop to input in job entries. For example, for I equals 0, I is lesser than n, I++, which is used to input the aforesaid in-job entries. During each input, the input will be executed in the JB array. First, input S and then E to save the starting time. And the ending time of each job entry. What will be next? Because we need to select the job that should be finished first, so you must sort these jobs. How do we sort them? Remember how sort is used? To use sort, you need to include the algorithm data. After including the required data, you will be allowed to execute sort. In sort, you're required to log in the array that will be sorted and the number of arrays that will be arranged. Next, you need a comparative function. In order to sort this array according to the comparative function, then how should this comparative function be written? When using the comparative function, we usually return true or false. Therefore, you're required to create a Boolean comparative function. This function contains two items representing two jobs that should be compared. For example, job A and job B, and they're required for the comparison. Regarding the element to be returned, it depends on which job is completed first. Therefore, the job that is completed first will be arranged at the front. Among the two jobs, the one that is finished first will be arranged at the front, and this is the so-called comparative function. What do we do next? Now you have created the structure and the comparative function. After executing sort, you will have a sorted working array. Next, you need to find out how many jobs can be executed. Let's take a look. First, you need to create a variable answer. That should be equal to 0 at first. Answer is used to save the number of jobs that can be executed. Then you use the for loop to run all jobs once. For I equals 0, I less than n, I plus plus. So what do we need to determine? You need to determine whether the two jobs have overlapped. If they have, then you cannot select the job. Otherwise, you may select that job. What we care is the ending time. The sooner it ends, the better it is. Here we have already sorted these. In other words, take 1-4 for example. 2-6 will follow it. Then we need to see whether 2-6 overlapped with 1-4. How do we determine whether they are overlapped? We can check the starting time of 2-6 and the ending time of 1-4, the size relationship between them. If the starting time is greater than the ending time, then they did not overlap. If smaller than the ending time, it means that they have overlapped. Therefore, we need another variable to record the duration of the final ending time. Then we use a now to record the current ending time required for the entire job. Because time still remains at the beginning, so it will be -1. After adding this job, if its starting time is greater than or equal to the ending time of the previous job, it means that they did not overlap. In other words, once this condition is met, this job can be added to our jobs. After being added, our answer will display plus plus in order to add another one, and then you need to update the ending time of the current job. It means that you need to update the ending time of the newly added job, and then it will be accepted by the PC. Finally, you need to output the answer. And you will know how many jobs can be executed by the machine. Let us run the entire program. What is this? There was a mistake just then. Oh no, I forgot to add a semicolon here. We see that it is written as 25, but there isn't any semicolon before the quotation mark and the big parentheses. Therefore, it means that we forgot to add a semicolon here. Let us run it once again. Now it can be executed. Let us paste our data for outputting, and there are 3 data entries that are correct. Please submit them for checking. Yes, the test has passed. This is the program code for this subject. You can try writing it yourself. Let us look at who finishes the supper first in greedy algorithm. Let us assume that in-persons are taking their supper in a restaurant, and the time required by the chef to cook each cuisine is also different. The time required for each person to finish the meal is not the same, and the restaurant will be able to prepare the cuisine one at a time. How should the chef arrange his cooking sequence so all of them can finish their supper and leave the restaurant as soon as possible? Next, let us look at the input and output instructions. Input instructions input several entries of test data. The first line contains an integer n, representing n customers are having their meal. If n equals 0, it means our test data have ended. Next, input n lines with each line containing 2 integers c and e, representing the meal preparation time and the dining time of each customer respectively. In this case, n is smaller than or equal to 150, whereas c and e are between 1 and 150. Output instructions output 1 line for each test data entry, and it means the leaving time of the last person under the optimal cooking conditions for the chef. Then let us look at the format of input and output examples. As a first step, input n. If inputting 2, it means 2 persons are having their meal. 11 refers to the meal preparation time for the first customer, and 8 represents the time required for this person to finish his meal. 7 refers to the meal preparation time for the second customer, and 10 represents the time required for this person to finish his meal. Next, n equals 3. Here you may input n repeatedly. When n equals 3, it means that there will be 3 customers, and the representing digits are c and e, which refer to the cuisine preparation time and the dining time respectively. Finally, n equals 0. Here it means the input process is ended. Therefore, there will be 2 sets of test data, and we need to output 2 sets of data. First, the first group of data refers to the total dining time of these customers, and it is the total meal time being spent by the last customer to leave the restaurant. As for 7, it refers to the time being spent by the customer before he leaves the restaurant. Then let us see how this subject should be solved. Same as above, you need to create the required format. In order to create the primary program code field, what should we do next? Because it is required to input n, so you need to set up n. Because it can be input repeatedly, so we use while to run while cn. When n equals 0, input is ended. Therefore, you are required to check if n equals 0. If n equals 0, then it should be ended. In order to break the while cin loop, what do we do next? After inputting n, the PC will input the cuisine preparation time and the dining time according to n number of customers. So we also need the C and E variables. Execute the input process according to the size of n. If I equals 0, I is less than n, I++. You may start the inputting by entering C and then E. Here, C and E should be tied together. Same as above, you may solve the problem according to the structure method. However, let me teach you a special trick here. Create an array containing sufficient capacity. And then save the C and E related data in this array. Save them together. But how do we do that? Because C and E are between 1 and 150, you only need to multiply them by a larger number, such as 1,000 and 10,000, and add another number, then they can coexist. If C and E are 99 and 54, for example, they can be 540099. And then you can easily differentiate which is which. But should C or E be placed at the front position? Here, our greedy selection strategy will be involved. Our strategy will be that you need to prepare the cuisine for the customer who takes longer to eat first. As such, his cuisine has been properly prepared, which allows him to take his time to enjoy the meal. Therefore, E will serve as important comparative data, and it should be placed at the front position. And then it can be solved by adding a larger digit. This way, you can save two sets of data in the same array. What should we do next? As you know, we need to sort them. For the sorting process here, we will use quick sorting. Same as above, you need to include the required elements. But how should quick sorting be used? Quick sorting requires the array size n, and the size of each element. Since our array contains integers, the size of each of our element is the size of the integers and our comparative function. Then, what should be included in the comparative function? When using comparative function, you may return int. Here, the comparative function is slightly complicated. It grabs the positions, to compare A and B. It will return the result to indicate whether A is bigger, the same, or that B is bigger. Since we want to sort them in the order from large to small, it should be done by deducting A from B. And then return the result. What should be done after they are sorted? After sorting, start the calculation. The total meal preparation time and the customer's total dining time. Therefore, you need to create two more variables, and they are cuisine preparation time and dining time respectively. Check all customers for one round, and then begin the cuisine preparation by starting from the customer that finishes the meal the slowest so that he may have time to enjoy the cuisine. This way it will not affect the store closing time simply because his cuisine is prepared last and it takes too long to eat. That would be troublesome. Since we just say both C and E in the VI together, so now we need to extract them out from value I. E is the quotient that we multiplied by 10,000 earlier. So now we will divide it by 10,000 and the quotient is E. How about C? It is the remainder. By calculating the percentage and 10,000, you can acquire C. C will be added to my preparation time. But did you realize that I forgot to set the initial value? So let's set the initial value and make them equal to 0 at first. The preparation time is acquired by adding the cuisine preparation time. Therefore, you should start the preparation soon after knowing the time required for preparing the cuisine. After knowing the time required for preparing next cuisine, start the preparation. Then how about the dining time? Should the dining be added directly like the preparation time? It seems incorrect, because the first customer may require 3 hours to finish his meal and it seems super long. Maybe the customer who comes in between doesn't even take 3 hours to finish his meal before the last customer leaves the restaurant. Then my dining time will be the aforesaid 3 hours spent by that customer, without the need of adding the dining time of other customers. It is simply because customers' dining times can be overlapped. For this reason, I will check the current preparation time when calculating the dining time, and then add the dining time for the current customer to see whether it will exceed the current total preparation time plus the dining time of this current customer. If exceeded the dining time of the last customer, then we need to update our data by changing the total dining time to the present status. What does it mean? Let us explain with the following example. Let's assume that the cuisine preparation time of a customer is 3, and he needs 11 minutes to finish the meal. Let's assume that the cuisine preparation time of another customer is 2, and he only needs 4 minutes to finish the meal. Therefore, you start preparing the cuisine for the first customer, and the preparation time will be 3 minutes, and then let him enjoy the meal for 11 minutes. It means that the present C time will be 3, and E time will be 11. Now you will need to check the conditions of our next customer. You need to add the cuisine preparation time continuously. Now the preparation time has become 5, and then the dining time is 4, so the total preparation time should increase by 4. Because it is not more than 11, so there's no need to add 4 here. Since he does not exceed the dining time of the first customer, he will leave the restaurant even before the first customer finishes his meal. This is why we need to make the judgment. If exceeds the time, we will replace the time. Otherwise, there is no need to change this dining time. Finally, you need to output the dining time to complete the entire process. Let's see what the program code will be like now. Oh no, one is missing again. Let's check what's missing. A semicolon is missing before 27 and it is here. Now, let us input our data, and it will be 26 and 26. It seems strange. Know why? The first one, 26, is correct, but 7 seems strange. It is because our dining time and preparation time have been reset to 0 before entering the restaurant. But you need to reset it to 0 when executing the input each time. Because the dining time and the preparation time should be restored to 0, therefore 0 should not be placed here at the beginning of the input process. Now, let's run this process once again. And we have the correct result. Now, submit it again. Correct. It is what we want, and it is the program code of who finishes the supper first. Those of you who have not yet written the program code can try it out. Let us talk about the backpack problem and greedy algorithm. It is the backpack issue that can be segmented. Let's assume that we have n pieces of objects and one backpack, and that the load capacity of the backpack, as well as the value and the weight of each object, are already known. You may separate the objects and then put some of them into the backpack. Now, acquire the maximum value of all objects that have been loaded into the backpack when calculated within the load capacity of the backpack. Next, let's talk about input and output instructions. Input instructions. Input n digit each time, where n means the quantity of the object. However, the aforesaid n should be less than 100. After that, input n lines with each line containing 2 integers. For example, w and v, for which w means the weight of the object and v means the value of the object. Finally, input an integer k to represent the load capacity of the backpack. Output instructions. Output a value rounded off to the second decimal place to represent the maximum value of all objects that have been loaded into the backpack when calculated within the load capacity of the backpack. Let us look at the format of the sample. First, input 3, and it means that there will be 3 objects later on. Each input contains 2 digits, and they are w and v respectively. The value of the object representing weight 6 is 12. The value of the object representing weight 4 is 4. The value of the object representing weight 7 is 21. The final digit 15 refers to the load capacity of the entire backpack. Now we know that 6, 4, and 7 represent the total weight of the merchandise, and they will exceed 15 when put together. For this reason, you cannot load all of these 3 merchandises into the backpack. In this case, you can select the merchandise presenting higher CP value and then put it into the backpack. How do we determine the CP value? You may acquire this value by dividing the value with the weight. Like the first object, its CP value should be 2. As for the second object, its CP value should be 1 only. The CP value of the third object should be 3. Therefore, you should select the object presenting highest CP value and put it into the backpack first, followed by the object presenting the second highest CP value. If there is any space remaining, you may put the third one into the backpack. Even though we load the entire 7 objects into the backpack, they will not exceed the 15 upper load limit, and so 21 is indicated to represent the resulting value. Next, load the objects of 6, and it will become 6 plus 7 equals 13, which is still within the 15 upper load limit. Therefore, 33 is indicated to represent the present value. Finally, 2 load spaces will remain, and you may load the object into these 2 spaces. In case of 2 spaces, the value will be 2, and then you may load other objects proportionally. Then it should be calculated as 33 plus 2, which means there will be 35 total value. Then, how should we write the program code for this problem? Same as above, create the required format first. For example, include IOStream, using namespace stand. Next, create the desired primary program code field, and then execute return 0 step. After creating the required architecture, let's take a further look. To begin with, you need to input digit in, and then input in pieces of objects along with their weight and value. Therefore, you need to create a variable in first, and then log it in the PC. Because these objects are tied together, so a structure can also be created for them. After creating the structure for the objects, you may log in the weight of the object, the value of the object, as well as an important element, the calculated CP value. Here we use VW to express the CP value, and it is the result by dividing V with W value. Now pay attention, because there may be decimal point after dividing V with W. Therefore, you're required to use double instead of using INT. After that, you may create the desired array, and now our structure is complete. After that, input the desired object because they're in objects, so the for loop should be used. For I equals 0, I is less than n, I plus plus. Here you may execute the input steps by starting with the weight W of the object, and then the value V of the object. After completing the input process, you need to deal with the so-called CP value, and it is the result obtained by dividing V with W. Now, let's perform the calculation. And VW is used to save the result after dividing V with W. However, it cannot be presented directly in this way because you may encounter certain problems if written this way. Let us check what kind of problems there will be. Let us see out our VW for you. Same as above, you need to input 3 objects. First, you need to input a value that can be divided, and it will be 1. Next, let's input a value that cannot be divided, and it is also 1. Does it seem strange here? You may input 5 and 9, and it is still 1. It is because that V and W are presented in integer pattern. When processing them by division method, their result will be still the integer value. Therefore, it should be specially treated by converting it to double pattern. Now, let's see what VW will look like. Same as above, there will be 3 objects. Here, 4, 4 will become 1. Then how about 4, 6? It will be shown as 1.5. Then how about 3, 7? It will be shown as 2.33333, and it is the result that we wanted after being calculated. So, you need to remember that the pattern should be changed. After completing the input steps, what should be done next? After completing the input steps, you need to load the objects into the backpack. Here, you need to load the object presenting higher CP value, and it means they must be sorted. Remember how sort is used? Same as above, you need to include the objects required for sort. So that you will be allowed to use the sort function after that. In sort, you need to load the array that you want to sort, and the number of objects that will be arrayed. Then write to determine which comparative function should be used for sorting. After that, you need to create the required comparative function. Normally, the comparative function will be used to return true or false, and it is a Boolean comparative function. It contains the objects that will be compared, and they are object A and object B. When returning, they will be returned according to the CP value of the object. The object presenting the higher CP value should be placed at the front, and so you need to return A.VW being greater than B.VW. This is our comparative function. After being processed, the PC will sort objects according to the level of CP value. What do we do next? Finally, we still have one more input to be executed. Keep that in mind. The PC will input the load capacity of the backpack, and you need to see in this K. After knowing the load capacity, you can put all objects into the backpack one by one. Finally, you need to output a total value. Same as above, you need to create a variable total V for the value, which is also 0 at the beginning, and then you may add the value of the object one by one. As previously mentioned, the value may have decimal points because we need to split them. There will be value carrying the decimal point after that. In this case, our total V must be the pattern carrying the decimal point. Next step is loading the object. You need to check each individual object and then stuff them into the backpack until the backpack is fully loaded. Therefore, you need to check each individual object by starting from I equals 0 and then the value smaller than n. During the stuffing process, you need to check to see if the object is exceeding the load capacity of the backpack. If it does not exceed such value, you may load the object. Otherwise, it cannot be loaded. Therefore, they should be carefully arranged. Now, you can load the object starting from the one showing the highest CP value. So you need to see if it is higher than the load capacity. If not, then it will be judged as smaller than or equal to status, and you may stuff the entire object into the backpack. By adding up our value, it will become the value V of the object. Because the objects are loaded, the load capacity of the backpack should be reduced. Deduct the weight of the object just loaded, and then repeat until they are properly loaded. What? It cannot be loaded. What do we do now? If the object cannot be loaded, it could be that only 2 spaces are left, just like the previous situation after 6 and 7 were loaded, but 4 spaces are required for the entire object. Therefore, you have to split the object until only 2 spaces are required to load the objects. Then you may stuff the rest of other objects into the backpack as much as you could. Based on the CP value of the object, you need to multiply our object with the remaining load. Like the previous case, 2 is left for the load capacity. By dividing 4 with 4, and the VW of this object will become 1, then you will be allowed to stuff 2, 1. After that, the comparison will not be required because the entire backpack is fully stuffed. So, let's output the result and see what result can be achieved now. You need to output this total V. Input the example, and you can see that 35 is indicated here, and it seems quite similar to the answer. However, we need 2 decimal points. Remember how to display and control the decimal point? To control the decimal point, you need to execute include step. First include the required objects and then create the decimal point. Now, let us recall how to deal with the decimal point. At this time, you need to make a note for previous program code and then check how to create the decimal point. We can set the decimal point by setting precise values. For example, I set the precise value to 2 and then display 3.123. Let's try this and see what kind of result we will have. We see that 3.1 is shown. Then let's change it and see what other kinds of results there will be. I don't know how much you remember about setting decimal places. Let's try this. Set up 13.123 and then set the accuracy as 4. Here you can see that it has become 13.12. It is set based on the number of digits you have. Can we control the decimal places only? Certainly you can. By doing so, you need to add an additional fixed. With this added, you can control the decimal point only. Let's take a look at the results. Regardless of the number of decimal places, and no matter how many digits are lying ahead, it will help you execute the control accurately. When inputting 2, it means 2 decimal places. When inputting 4, it means 4 decimal places. Next, open previous program code again, and then you may fix it at 2 decimal places. Run it again like this. Input the value and then output it. Here, it's 35.00. This is the result that we wanted. Now submit it again. Correct, it has passed the test. Come and try this problem out. Let's talk about the subject of strengthen the immunity by eating fruit in greedy algorithm. Let's take a look at the problem. To fight against the COVID-19 pandemic, the entire world is under intensive alert status nowadays. In addition to washing hands, wearing face masks, and disinfecting the environment frequently, it is also crucial in strengthening personal immunity, especially vitamin C. In this case, vitamin C can be ingested through vegetables and fruits. Under the preconditions of not spending more than $M on buying fruit each day, you need to know which fruits to purchase in order to obtain the maximum content of vitamin C. Let's assume that the fruit can be sliced into gram unit for easier purchase, and that the amount of each fruit ingested is no more than 100 grams. Input instruction. Input digit N one at a time. Here, N means the total number of fruits, and N should be less than 0. After that, N lines will be indicated with each line containing 2 digits, and they represent the amount of vitamin C contained in each 100 grams of fruit and the price of each 100 grams of fruit. Finally, input an integer M, and it represents the daily maximum expense limit spent on fruits. Output instructions. Output a value rounded off to the second decimal place, and it represents the maximum vitamin C content that can be ingested within the daily fruit expense limit. Let's look at the input and output in the example. First, you input 6, meaning that there will be 6 entries of fruit data. Each line contains 2 digits, representing the vitamin C content in every 100 grams of fruit, and the price of every 100 grams of fruit. The last input represents the expense limit. Here, you also need to determine which fruit has the best CP value first. After that, make up $30 according to the level of CP value, and you will know how much vitamin C content will finally be ingested. Let's look at how this program code should be written. Same as above, create the format as a first step. Include IOStream, and then using namespace stand. Next one is primary program code field. Do not forget to execute the return 0 step. To begin with, you need to input in. Therefore, you need to create a variable in to execute the input. After finishing the input step, input in kinds of fruit together with the vitamin C content per gram and price per gram. In the same way, you need to create a structure. This subject is very similar to the previous one, and you may use it. Same as above, it should be represented by weight as well as V, W, and V. Since we are calculating the CP value, we will also use VW, and it is the result acquired by dividing V with W. Then create the number that will be required. Because N is less than 100, you need to create 101 structures. After creating the required structures, next is the input step. Input the content of each fruit and its price. Now, try to figure out which one is V and which one is W. V is our value, and W is the portion that cannot exceed the backpack limit. Therefore, the limit should be the amount. This means that the amount is our limit, which is the price. The price cannot be higher than our maximum expense limit. Here, price is the so-called W, and the vitamin C content is the so-called V. It means that you need to input the vitamin C content when executing the input step, and it refers to V. Next should be the price, and it is the so-called W. That's the correct thing to do. It should be treated very carefully. Next is the CP value. Same as above, you are not allowed to express VW as dividing V by W directly. This way, you will get the integer result. Because both of them are integers, you will get an integer after dividing them with each other. Here, you need to force the conversion into the double pattern. This way, you may have decimal point after saving it. Next, we need to sort our CP values using sort. And it should include the array and the quantity to sort, and our comparative function. Do you know how to write comparative functions now? Return a Boolean value. In the comparative function, load the following two objects. Object A and Object B that will be compared. After that, return the results of the values you want to compare. You may hope that the object bearing higher CP value should be placed at the front end as much as possible, and it should be executed according to CP value. If CP value of Object A is higher than that of Object B, then return true. And it allows you to sort them according to the level of CP value. After being sorted, you need to input the upper expense limit and it will be K here. After inputting K, let's see which fruits we want. Same as above, create a total V first, and it will be indicated as 0 at first. After that, check all of the fruits to see which ones we want. Certainly, the fruit showing higher CP value should be selected first. If the space is still enough, load as many fruits as you can buy. Load all 100 grams directly as long as they do not exceed our amount limit. After loading them, you need to increase the vitamin C content as well. Therefore, increase total V until it is equivalent to our vitamin C content, and it is V. Then the amount in the wallet is reduced, which means W is reduced. If the amount in the wallet is not enough to buy 100 grams, then you may buy some of them. At this time, you may slice the fruit and it becomes our OB. VW means the sliced portion, and you need to make the purchase according to the amount remaining in the wallet. After completing the purchase, you may quit this loop because you cannot make any more purchase afterwards. As a final step, you need to execute the output. Now, let's see what result we will get. Oh no, something's missing. Yes, you forgot to include the object when executing sort. You need to include the result of our algorithm. And here's another mistake. Because you have forgotten to add the semicolon in line 32, let us run it again. The result is 497. It is a correct answer, but you haven't solved the decimal point problem yet. Remember how to deal with a decimal point? Let's add the objects that should be included. To avoid forgetting to include the required object, like we just did with the sort step, okay, next you need to deal with the decimal point. And you may execute such job by setting up the desired accuracy. It is not enough to just set up accuracy 2. It will display a total of 2 digits according to your number and your decimal point, remember? Therefore, you need to use fixed to process the decimal points only. This way, you may display 2 decimal places constantly. And then 497.00 will be displayed. Make a comparison. It has passed the test. So, that's the solution for this problem. Try to write the program code now.